All right, so for this video, I'm going to be giving you a demonstration of how to run an analysis on Q-method data using the CanQAnalysis website. So this site will do a full Q-method analysis in your browser and give you all of the outputs that you need to interpret your data and draw your conclusions about what you found. So you just go to the CanQAnalysis website, which the link here is in the materials you've been given. You can also just Google CanQAnalysis and it'll pop right up there. You know, that's not a name that's used for anything else, so it's pretty easy to find. So you go here. You of course have to have one of the standard browsers to do this. So I'm in Chrome, I'm all good. There's a reference manual so that if you have questions as you go along, you want to review things, you want to look at some of the more detailed things that you can do that I'm not going to cover in this video. You've got the manual there, and there's links to some of these other tools. So, we've used the EasyHTML to gather our data, and there's links to it here. There's a desktop edition. I've never used the desktop edition because I've been able to do everything I need to do in the browser version, but if you prefer to be able to work offline with a desktop application, you can download that there. But so the first step we have to do is we have to input our data. So the CanQ website will actually take data in a number of different formats. So you can upload CSV, Excel. This tab here is for EasyHTML. So this is where you'd be uploading your files if you're using that method to gather your data. I've actually uploaded data from PQmethod because that's just where my example data was living. PQmethod is an older DOS-based Q-method analysis program that was kind of the standard, the most popular program for a long time until a few years ago when CanQ came out. So a lot of my older projects are still in PQmethod format. So you just click to upload there, which I've already done, and you'll notice there's this checkbox here. This is on all of the different data formats to tell it whether your sorts are forced or unforced. So that means, did you require people to exactly fit that distribution of statements, how many in each column or not? So CanQ can work with unforced sorts. So when you're doing an online data collection, the Easy HTML queue kind of pushes people to do a forced sort, to make their things fit that format. But when you're doing in-person data collection, sometimes you'll find that somebody just can't make it work. They're just not willing to do that. And so you can actually allow them to have different numbers of statements in the columns than you intended, and you just have to tell CanQ that you've got unforced data there because it's going to handle it just a little bit differently here. So I've uploaded my data already, and you can see the website's got it on here already. So it knows my number of statements, participants, the design. So this is the distribution of statements. I have 4 at the -4, or sorry, 3 at the -4, 4 at the -3, etc. Got the statement list here. My statements here, these are from the environmental justice study that you looked at. And in PQmethod, statements get truncated just because it's an old program. It can only handle so many characters at a time. But I've got enough here that I can, remember what the statement was as I interpret it. Then we've got the actual data from all of our participants here with how they sorted things. So then we can just hit begin analysis. And so the first thing it's going to give us is the correlation matrix. So this is just a table that shows how much each individual's Q-sort correlates with the others. So my first respondent obviously correlates 100% with themselves and correlate 38 or 0.38 correlation coefficient with the second person, 4.2 with the third person, etc. So this is the basic material that the Q analysis is going to work with. It's going to take this matrix of correlations between all the different individual sorts and then try to, from that, pull out what we're looking for from our results. So now we have to extract factors. All right, so we're going to take this whole variety. I had like 42 participants there, and we're going to turn it into a smaller number of factors. And so there's two choices that you have to make here. So you have to decide if you are going to do a centroid factor analysis or a principal components analysis. And so there's a huge amount of debate within the Q method community about the virtues of centroid versus principal components versus other forms of factor analysis. And so with KenQ, you can only do principal components or centroid. There are Q method packages that work in programs like R or SPSS that will allow you to use other factor analysis methods that are out there. Excuse me. And so, like I said, there's a lot of debate about it. You can read up on it on the literature. What I have found with my own research, I've done a whole bunch of Q studies, and I will often look at it. I'll do both. I'll do a centroid and I'll do a principal components. I have never, in all of the studies that I've done, found that it actually makes much difference. The resulting factors are very similar regardless of which factor extraction method that I use. So I personally don't worry about it too much because I've just never found it to make a huge difference. So we have to decide how many factors that we want to extract. And so this is something that you kind of have to do trial and error. So you can try it with different numbers of factors, see how well the analysis comes together. Try it with a different number of factors, see how well the analysis comes together. Right? You're looking, when you're doing this factor extraction, you want to try to explain as much as possible of what's going on, right? Incorporate as many of your people, find these shared perspectives that exist within your data, but without having so many factors that it gets complicated to try to analyze and explain everything that's going on, or that you're getting factors with only one or two people defining them, because the more people that you have defining a factor, the more you can trust that this factor represents a shared viewpoint, something that is common to a group of people, that you're not just putting in the idiosyncrasies of just one person, unless that person is in some way especially important in your study. They're not just another participant, in which case maybe you do want to be able to have a factor that represents just that one highly influential person's viewpoint. So just to give an example, do the example analysis, I'm going to extract 4 centroid factors here. So it has run the analysis and it's got our factors, and so what it's showing here is the loading of each participant on each factor. So how much does that person's individual Q sort resemble the factor itself, like the core shared concept of the factor. And then as we go down here, we have a few pieces of information to help us decide if this 4-factor solution is the best. And so we've got eigenvalues here, which I won't go into exactly what those are. It's a math thing that you can look up if you're interested, and the amount of explained variance from each factor. And then you can graph these on what's called a scree plot. So this shows, how much variance is explained by each factor as we go through. The first one is always the biggest because that's kind of what factor analysis does. It looks for the one factor that can explain the most of what's going on, and then of what's left, what's the next factor that can explain the most of what's going on. So it's going to go down like this. And one way to think about choosing the number of factors is to look at this scree plot and to look, number one, for is there sort of a sharp bend in the scree plot. Right? Does the scree plot go down and then kind of flatten out? Because at that point where it flattens out, your new factors aren't really telling you much more. You also want to look at where the number 1 is. So a eigenvalue of less than 1 means that that factor has less information to it than a single person's Q-sort. So usually you would not want to keep more factors or keep factors that go below 1 in their eigenvalue. So you can see this factor 4 has an eigenvalue of only 0.27. So that is strongly suggesting that maybe I don't need a 4th factor in my solution. Maybe that just 3 factors would be enough to explain my data well. That is not a hard and fast rule. That is not a thing that you're doing your analysis wrong if you're keeping more factors. But it's a consideration to take into account. And so if you're going to keep more factors than that, more than the eigenvalues and scree plot suggest, you probably want to have a reason for that. You want to have something that, well, if I put this 4th factor in, it highlights this additional important perspective that would otherwise get lost. So you may want to, at this point, continue with your 4-factor analysis and just see what happens with that 4th factor. See what it tells you and see if that's something worth. If you do decide that you want to go with just the 3-factor solution, then you can just scroll back up here and you can reset the analysis and rerun it with fewer factors. So let's try that, and we'll just do 3 centroid factors this time around. So it's going to look very similar. We just lopped that 4th one off. So we'll continue with our 3-factor analysis there. So the next thing that we want to do is to rotate our factors. So we're going to rotate all 3 factors. So what factor rotation does is it takes this variance that our factors are explaining, and rather than trying to maximize the first one by itself and then only with what's left trying to do the 2nd factor and so forth, we're going to try to distribute that more evenly. And the effect of that is to distinguish these different perspectives that exist within the data. So I'm going to rotate all 3 factors here. Okay, it's going to work on that. Okay, and so then you can do either a judgmental rotation, also known as a hand rotation, or a Varimax rotation. So Varimax is a statistical algorithm that if you apply Varimax rotation, it spits out an answer. This is what Varimax says is right for rotating your factors. Sorry, somebody's trying to call me while I'm recording this. Judgmental rotation is rotating by hand. So you're actually looking at the factors and making your own judgment about how to rotate them. So I'm going to hit judgmental rotation just to show you what's going on, because this will help you understand what this whole rotation thing is all about, right? Because just clicking the Varimax button, you don't have any idea what's really going on behind the scenes with math there. So with judgmental rotation, I'm going to select 2 factors to rotate. So we're going to start with factors 1 and 2, and we're going to display them as a 2-dimensional graph. And so what we've got here is here's factor 1 as one axis and factor 2 as another axis. And so we can rotate this. So let's rotate 5 degrees at a time, and we can rotate clockwise. And you'll see how as the colors of these sorts change, right? Each of those little dots there is a Q-sort. Right? That's one person's Q-sort. And you can see as we rotate it, it changes which Q-sorts belong to which factors. And so if I rotated this about 30 degrees counterclockwise, we've now got kind of one cluster of people that are loading highly along factor 1. Right? They're very close to the high end of factor 1. We've got this other cluster that's getting close to the high end of factor 2. I might actually rotate just a a little bit more there. All right, so we're distinguishing these two clusters of people, one associated with factor 1, one associated with factor 2. And so we could save that rotation, and then we could rotate factors 2 and 3. So you rotate 2 of them at a time because you're doing this in 2 dimensions. So if we show 2 and 3, so again, we've got this plot. You can see, there's all these people that are not part of 2 or 3. And again, we can rotate this in various ways. We can see if we can get more people clustered onto one or the other of these factors. So when you're first working with data, it can be really handy to go in and do a little bit of judgmental rotation just to help you get yourself a sense of what's going on in the data. How is it put together? What kind of clustering do you have of these Q sorts within your data? And that's useful to help you understand what's going on, even if you then decide to go and run the Varimax rotation. Because if what you're doing is just trying to distinguish people into separate factors like this, Varimax will do that in a more exact fashion than judgmental rotation will. Varimax is more qualified to make that judgment than you as a fallible human being probably are. But you'll learn something about your data by playing around with it through this judgmental rotation. The other handy thing about judgmental rotation is that you can use that if you want to do something other than simply trying to distinguish clusters of people onto different factors. Because that's all Varimax can do. It gives you an answer. But with judgmental rotation, you may be looking at, so how do the other perspectives relate to a particular person, for example. So let's say that this person number 5 here is somebody that I'm particularly interested in. They're not just another participant. There may be, the leader of the NGO that you were doing your research on. And so you're interested in seeing how the perspectives of the other participants relate to this leader's perspective. Or maybe this person 5 is you. Maybe you've put your own Q sort into this, and you're interested in how these different of the other perspectives relate to your own perspective, right? How do these connect with you? This is something that I did with this data actually, because my Q sort was in there. I forget which number I am. I think I'm whatever the highest one is on here, because this was data gathered from my students, and so I wanted to see how their viewpoints related to my viewpoint as the teacher. You might also have a theoretically constructed Q sort in here. So if you are testing a particular theory about what people think, you may have created or constructed an artificial Q sort representing an idealized version of a certain point of view. And then you want to see how that point of view relates to the actual viewpoints expressed by your, real human participants. And so one way that you can do that then is you can rotate so that your sort of interest loads very highly on one factor. All right, so about there, I can fine tune it here. About there, I've got this sort 5, if this is our person of interest, I've got them loaded very highly onto this factor 2 here. Right, and then everything else is arranged relative to this sort of interest. So those are some of the kinds of things you can do with judgmental rotation that you can't do with Varimax. But in most cases, if what you're trying to do is just say, what are the major points of view that are out here? What are the most common shared perspectives that people have? Then Varimax is going to be able to do that. So after you've explored the data a bit with judgmental rotation, we can just hit Varimax rotation, and it will do our Varimax there. So we've now Varimaxed this, so we've got our rotation. So now we need to flag our factors. So what we're doing here now is saying, okay, these sorts are highly correlated with factor 1 and less so with any other factors. So we're going to use those to define what factor 1 is all about. We're basically going to average those sorts together, weighted for how much they correlate with that factor. And that result is going to be a Q-sort that describes that factor. Okay, so we're going to average together all those factor 1 people to create this idealized, this is what the factor 1 people have in common in the form of a Q-sort. So what we're showing here is, now that we've done all the rotation for each of our people, how much do they correlate with each of these factors, right? And so you can see, for example, this person number 2, they correlate at 0.8291 with factor 1, a negative 0.05 with factor 2, only a 0.22 with factor 3. So this person very clearly is expressing factor 1, right? Factor 1 is going to describe this person's viewpoint pretty well, right? Not perfectly, it's because it's not a correlation of 1, but pretty good. And then they've got them kind of ranked here according to how closely they correlate with factor 1 for all of the people who factor 1 is their highest correlation. So we're now going to check off the boxes for the people that we want to represent factor 1, and then likewise for 2 and 3. And so the easiest way to do that is just to auto flag. So just have the computer do it. A p less than 0.05 is kind of the standard, so you can just hit that auto flag and you'll see that it sticks these checkboxes in here, right? For everybody that's at least a 0.05 correlation with their factor and not anything similar with the others, right? Because you see person 11 here, they're a 0.5666 with factor 1, but they're also, 0.46 with factor 3. So they're kind of, on both of these factors. They have things in common with both of these. So it's usually handy to start with that auto flagging. You can change the significance level here, but then you can also look through this and fine-tune it based on your judgment calls that you might want to make. So maybe we do want to say this person 1, we actually do want them to contribute to factor 1, but then maybe we also want them to contribute to factor 3 as well, because they have a lot in common with both of these. This automatic flagging, if somebody is split like that, if somebody shares viewpoint elements with multiple factors, it will flag them as nothing. You may want to flag them as both, so that their contribution goes into both of those factors. And so these are judgment calls, right? There's no hard and fast rule about how you do it. It's another thing where you may want to do it one way, run the analysis, see what comes out, then go back and run it a different way and see what comes out. See if what comes out the other way makes more sense, is easier to explain, makes more sense to your participants, because your final step is always to share the results with the people that did your Q-sorts and get their feedback. Does your analysis make sense to them? Does it seem to capture how they understand things? So you can go through and fine-tune these flaggings. I'm not going to spend a bunch of time on that right now, so that I can show you the rest of how the analysis works. Another thing you can do here, you can invert a factor. So if you have one factor that has a whole bunch of very high negative correlations, you can flip it around so that, what you essentially got is a factor that expresses kind of the opposite of what all these people think. You can flip it around so that it matches what they actually think. And sometimes you may have a factor with very high positive and negative correlations on it. That's a bipolar factor. One of the things we often find with Q-method is that it shows us that our viewpoints are not bipolar, right? That we don't simply have the pros and the antis that have exactly opposite views from each other. But sometimes we do find that you actually do have two groups of people whose views are essentially opposite for each other. The factor analysis will turn them into a single bipolar factor, right? A factor defined by some people that are very strongly positive correlated, and other people are very strongly negative correlated. You can use this button here to split that so that you're working with two factors, so that they're representing these two different, the pro and the anti-viewpoint as two separate factors rather than just two ends of a single factor. We don't have a bipolar factor in this particular data, so I'm not going to do that, but that's a thing that you can do if you do have, again, a factor with some very high positive and some very high negative correlations that therefore is representing these two essentially opposite viewpoints. Okay, so then we're going to hit generate output. So this is going to give us, we're going to do all three factors here. And it's just warning me that I had flagged a QSort for multiple factors. Oh, it doesn't like that. Sorry. Let me go uncheck that. Now hit generate output. There we go. All right, so now we've got our outputs, and you can download this whole thing so that you can look at it later so you don't lose it if you close your browser window as an Excel or CSV, but I'd also show you it here in the browser. So all of what you're going to see now is information that you're going to use to interpret your factors and to figure out what's actually going on and draw conclusions. So first table here, correlations between factor scores. So this shows how much your factors themselves are correlated with each other. All right, so you can see factor 1 and factor 2 are correlated 0.37, so there's some commonalities but not a ton. Factor 1 and 3 are correlated 0.51. So there's some more substantial similarities between what factor 1 and factor 3 think. And then 2 and 3 are correlated 0.41. So that's something to keep in mind as you're interpreting this, is that factor 1 and factor 3 are going to have a lot of commonalities. There's going to be similar things. You're going to be wanting to look for what are the subtleties of differences between these while also recognizing those similarities. All right, factor characteristics, number of defining variables, so that's the number of people that define each factor, their average correlation, and then the z-scores, which we'll get to in a little bit. Then you can visualize these factors. So now what we've got here is a composite QSort for factor 1. So that means we've taken all those people in factor 1, we've averaged them together. So this is the average of what those factor 1 people think. And first important step in your analysis is to look at this and say, okay, what's going on here? What is the viewpoint? Right? If I'm going to take this arrangement of statements and describe in kind of narrative form what these people think, how would I do that? So there's a few things that you want to look at here. So one thing you want to look at is you want to focus a lot on the top and bottom categories here, right? These are the statements that were most like how they think and least like how they think. So this factor, there are 3 top statements where all people should have equal access to the benefits of economic development, I think is that full statement. Like I said, these are truncated statements because of how PQ method, where I put this data in, works. You'd have your full statement here if you loaded it out of EasyHTML. But so all people should have equal access to the benefits. All species, human and non-human, should have equal rights. Nature has a right to integrity and freedom from interference. Right? So these are the top 3 things that this group thinks. So we can already start to see some themes, right? This is a viewpoint that puts a lot of emphasis on egalitarianism because the idea of equality is in 2 out of the 3 top statements here. And then if we're looking down at this -4, people should be expected to protect themselves from something about environmental harms. It's silly to try to preserve or protect pristine ecosystems. People should be free to treat nature as they wish. So again, you can pretty easily see, if you think about those statements, these are people that think that we need to do a lot to protect nature, right? And so they're very against these, like, we don't need to preserve pristine ecosystems. We can do whatever we want to nature. It's, you're on your own dealing with environmental hazards. These are things that this group really is against. And so you can probably already start to have a picture of what these people are thinking. And then you can go through, look at the 3 and -3 ones, see how that fits into the picture that you're getting here. You want to be careful as you go, not to jump to conclusions, because sometimes you'll start to look at these things and be like, oh, I bet I know what these people think, because you have this idea in your head of a certain viewpoint. That might not be quite right. So you want to make sure that you're grounding your interpretation in the actual Q statements that they've got. You want to check, so if these people, if I've got this idea of what these people think, then they probably liked, this other statement as well. Look, see where that statement was, make sure that that's consistent. Another thing that you're seeing here are we've got these asterisks and little arrows showing significant statements. So what this means here, so this all species have equal rights, you see 2 asterisks and a little arrow. That means that this was an extremely significant difference in how this statement was ranked between this factor and the other 2. So this factor really thought this equal rights statement was a statement they really liked, that they put really high, much more so than the people on the other factors. And if we scroll down here, and and they've got it, little key to that in there. If we scroll down and look for that statement, say in factor 2, let me find it here. Sorry, I should have looked at where this is gonna show up before I started recording here. Come on, where is it? There it is. Okay, all species have equal rights. So, factor 2, they're not against this statement, right? They're not putting this on the negative end, but they put it at a 2. It's not as important to them as it is to the factor 1 people. And then if we look at factor 3, let me see if I can, okay. Factor 3 also put it at a 2. Okay, so this statement doesn't distinguish factors 2 and 3. They both put it in the same column, but it does distinguish factor 1, because the factor 1 people really liked that statement, and 2 and 3 liked it, like they agreed with it, but they didn't emphasize it nearly as much. So that's another thing that you want to do as you're putting together your interpretation of these factors, is be comparing them. Look at where these important statements rank in one factor versus in another factor. So the result of this is you should be developing, as I said, a narrative that describes the viewpoint captured by each of these factors. And then as you do that, you can cite the specific factors to justify that narrative. So we might say that factor 1 believes strongly in equality or egalitarianism, and then in our write-up we would cite the statement numbers for these 2 statements here to illustrate that, right? To say we can say that they're really concerned about equality because of how they've ranked these 2 statements. Usually what I will do in my write-up is I just put in parentheses the number of each statement followed by its position in the Q sort. So number, whatever, I left the statement numbers out of the statement text here, unfortunately, but number whatever ranked at a 4 to illustrate that or justify that claim that I make in describing this viewpoint. So that's the primary output that you're going to get here. So you'll be able to use that to describe these factors. Usually it's good as you're preparing something for publication to actually include an appendix that lists all of the statements and where they're ranked in these different Q sorts. And then that gives you the basis for your interpretation. So your job now is to run the analysis using the data that we generated for our class study, and try to come up with an interpretation. Come up with a description of what each of the factors that you have chosen to include in your analysis. What does each factor think here? And what distinguishes them? What is similar about them? So you'll be doing that, and then on Friday we'll be looking at your analyses. We'll be talking about what you came up with, what roadblocks or challenges you ran into along the way, and then how to go from this analysis to something that might be publishable.